About it with Gauss's law.
So you can talk about what do we have to learn it?
Let me write down the statement first. Gauss's law said, oh, not math, it's electric.
It's electric.
Electric flux through a closed surface in the space is determined by the net charge inside the closed surface only. The charges outside surface has no contribution at all. And if you change this one into a formula, it looks like this. The flux basically equals the charge. But there is a problem here. If you put it down this way, this one has a unit of Newton times meters per coulomb, right? What's the unit for charge? Coulomb. There is a unit problem, right? If you want two things to be equal, they have to be the same.
Divided by Newton's meters.
Therefore, you have to divide it by something to make the units consistent, right? So here is a constant, which is epsilon 0. That's the one we learned. K equals 1.
Oh, yeah, yeah.
It is this one's called permittivity. It's the property of a constant determined by the material itself. That's the equation from Gauss's law. But we don't know the calculus so bad. In calculus, it looks like this. Very beautiful. Why we have two lines? One line means one-dimensional integration. Two lines means two-dimensional. Why? Because area is two-dimensional, right? So you integrate this. This is basically what? The flux. And the dA is a tiny area on the large one. You pick up a tiny one, as small as possible. This small part on this large area is called dA. And the integral means what? As I explained last time, it's addition, right? You pick up one piece here, then the other piece, then another piece. Until you finish everything, you add them up. That's the meaning of the whole thing. You do additions, basically. That's called integration. But this is calculus, not algebra-based The only thing you can do is just put this down, see? And actually we calculate the flux by using calculus. But right now we can do nothing. But we still can do something, even it's a little bit crazy, okay? All right. I have a closed surface, I tell you. There is one charge with the 5 coulomb and another charge here. This is negative 3 coulomb and maybe more. For example, 6 coulomb here. 3-point charges inside this surface, and right here I have a larger one, which is 10 coulomb. And over here, very close to this surface, is negative 50 coulomb. That's the situation, okay? 5 different charges. 3 of them inside, 2 of them outside. I want to know what's the electric flux through this closed surface.
Well, it's 8 coulombs
And then
over
charges.
here.
How do you do the calculation?
Add up the charges on the
Do
inside.
you touch this one?
No.
No, it's a constant. What's this thing here?
8 coulombs.
8? What?
If you add them all up.
11 minus 3.
Add 5 together?
The 3 inside.
No, only
Only
inside.
this.
Only
These
inside.
2, we don't care, right? It doesn't matter. Therefore, here basically 5 plus 6 minus 3. That's your solution.
I like that.
Even you don't know the size of this surface, it doesn't matter. The flux is a constant. Only depends on the charge inside. It doesn't depend on how large the surface is. Okay? And how large the surface is the problem here. That's how large it is. But you are not asked to calculate the size, you calculate the flux, right? So there's no such a thing as flux, therefore. It's so simple, right? Okay. Now we go to something a little bit crazy, but we can still do it. There are 2 examples. Both are in your textbook. And we need to look at them and solve them together. One is 14.5. It's on page 364. On page 364. This problem just has one line. It says, calculate the electric field produced by a point charge Q using Gauss's law. On page 364, which means you have one point charge Q here. You want to know the electric field around this charge. And what's the shape of the field around this point charge?
Circle.
Sphere.
Circle?
Sphere.
Is it sphere? I mean,
It's something like this. The field is going out from it.
every point in all directions.
Okay. Everywhere it's going out.
So like a color.
That's the field direction. Now, we want to know the magnitude. How strong the field is.
Never watched videos. She sounds so loud. Love touching it.
Okay. Follow me. There's no hurry to take notes. The thing is, you have to understand what's going on here, okay? If I pick up a point on this line, and this distance I said is R, from center to here, okay? Therefore, you will have a field that goes this direction, right? if I take the same distance here, put down another point, is the field here the same as the field here in magnitude?
Yes.
No, this distance is still r.
Yes.
Yes.
Okay, how about here? I take the same
Yes.
length here. Is the field here equal to this, equal to this?
Yes.
If you connect all the dots the same distance to the center, it's going to be a what?
Circle.
Circle.
You have a
Sphere,
circle
if we
here.
go 3D.
Which means any point on this circle, it has the same size of field.
Mhm.
Just different direction, right? The magnitude is a constant. If you draw another circle, all the points on that circle will be equal in magnitude also, right?
Mhm.
All right. This is a 3D picture, but we can only draw a 2D picture on the board, right? Imagine it's a sphere, basically. This line basically means a sphere, right?
Yeah.
Okay. We want to know how strong this electric field is. We just need the magnitude. We don't care about direction because it's labeled already, right?
All directions.
Okay. You see, you have electric flux equals E dot A, right?
Yes.
And this one, according to definition, is equal to the magnitude of the field times the area times cosine what? Theta. Theta is the angle between the area and the E. Then go back to this picture. Imagine this is a 3D sphere, right? What's the direction of E if you pick up any point here, for example, on the surface?
Away from.
Go along the radius, right?
Yeah.
This direction.
So it's
What's the
flat.
direction of A? You have a sphere, right? You just pick up a tiny area here. What's the direction of the area?
It's going inward.
Inward or outward, doesn't matter which way. It must be perpendicular to the surface. Your surface is
Yes.
here.
Must.
Therefore, this direction, the E direction and the A direction, they're basically the same, right?
Yeah.
Therefore, what's the angle?
0.
0. Okay. For this situation, this is 0 degree. Cosine 0 degree is what?
0. 1.
Are you sure?
I don't know. I'm just guessing.
How about sine
It is
0?
1. Cosine of 0 is 1.
It's
1.
Yeah.
Cosine 0 is 1. Therefore, this one basically equals E times A. All right. What do you want from this problem? You want to field the E, right? In order to find the E, you have to calculate A. What do you mean by A there? A is the area, right? What area in this picture?
Using the radius to find the area.
A circle or a sphere?
A
Sphere.
sphere.
A sphere, right? And a sphere, the radius is R already. If you know the radius, what's the surface area of a sphere?
Something about pi.
4/3
The volume we know is 4/3 pi r cubed, right?
Yeah.
Yeah.
But what's the surface area?
I don't know. I bet you know.
It's
it,
2
though.
pi r.
2
Or 2 pi r.
Is it 4?
Times.
Let's look in the back of
That's the formula.
Oh, 4 pi r.
4 pi r squared. If I give you a cylinder, can you calculate the surface area?